Okay, so there's another topic in section 4C. It's about impact between particles. So in this impact of particles, first we need to, there's a new coordinate system we need to set up. It's different from the IJXY coordinate system we used to use. Here we have a first coordinate system is called plane of contact. We use T represent this direction, and that is defined by is tangential. The plane is tangential to the contact surface for A and B. Another um, coordinate system is N. That's line of impact. So it's defined as a line that is perpendicular to the plane of contact for A and B. So in this type of impact problems, you will need to set up Tn as your coordinate system. And once you have the coordinate system, you can only just take a look at one of the particles. Take a look at A. If we only look at A, and A will have a force FAB. That's a force coming from particle P. That's an impact force. And on T direction, if we sum of all of the forces, T direction is a vertical direction. There's no other force on T direction, so the sum of the forces equals to 0. That means the conservation of momentum in T direction. And we can apply the impulse momentum equation. The left hand of the equation will be 0, since the sum of the forces equals 0. Then we can get this equation ma VAT2 equals ma VAT1. So that means on T direction and the velocity or speed of A, and it's the same before and after impact. And if we look at the Tn direction, sum of the forces on n direction, that's the line of impact, and we do have one force FAB, so sum of the forces is not equal to 0. Okay, so that's the analysis for particle A. Then we can take a look at particle B. Same thing from Newton's third law. And particle B, we have an impact force from A, that's FBA. And on T direction, sum of the forces equal to 0. We can use the conservation of momentum on T direction. Okay, MB baby T2 equals MB baby T1. And on n direction, we do have this force. So the sum of the forces equals FBA. And you can write that as negative FAB. FAB is an impact force in particle A. Okay, then since now we did analysis for A and B separately, we can look A and B together as a system. So when we look at A and B together, then if we look at the sum of the forces on both T and N direction, we will realize that there's no zero sum of forces on both directions. That means we have conservation for momentum on both directions, both T and N direction. And we can write it out to have the equation for n direction. We have ma van2 plus mb vbn2 equals ma van1 plus mb vbn1. And that's the third equation we can get from two-particle impact. And the next thing, it's a new concept. It's called coefficient of restitution. We use E to represent this coefficient. E equals negative VBN2 minus VAN2 over VBN1 minus VAN1. So make sure there's a negative sign in this definition. Also, all the speed v in this equation are on n direction. So this coefficient has some meanings. When the coefficient equals 1, that means it's a perfectly inelastic impact, which means particle A and B were impact, and after impact, they will stick together. And if this E equals 1, that means it's a perfect elastic impact. And so after the impact between A and B, they will bounce back and with no energy loss. So this is an ideal condition, but in reality, we always have this. In the real world, E will be less than 1. And for those type of impact problems, you can use the 4 equations above we mentioned. And impulse force, second thing is impulse force is has a large magnitude but has a very short duration. And during the impact, we usually neglect the non-impulsive force. And the impact force, of course, is an impulsive force because it has a large magnitude, short duration. And for reaction forces, sometimes they can be impulsive, but we will talk about that later when we have examples. But for wave force and spring force, always remember they're not impulsive. Third thing in this section is assume only A and B interact in the impact to use equation 1 to 4. If they're not interact with each other in the impact, you can't use equation 1 to 4. And before you analyze and solve everything, you need to make sure you clearly define the coordinate system N and T. Don't mix the direction. Make sure you find the right direction for N and T, and before you use equation 1 to 4. And the coefficient of the restitution E is only valid for velocity component in N direction. So make sure all the velocities in the E is on N direction only. And last, that's important to keep in mind is the mechanical energy is not conserved during the impact unless we have this ideal condition when E equals 1, which is a perfectly elastic impact. Otherwise, our mechanical energy is not conserved. Never use work energy equation during impact problems. All right. Okay, those are the concepts and some important notes for impact problems, and we're going to look at some examples.